So, you're all welcome to the class on as the topic shows, we are going to continue from where we stopped last week, and that is implementing your first machine learning based model in what we call the Hello World ML model. So, one of the aim and objective of our series, this is under the important clarification series, and following the principle of always let the data speak. So one of the aim objective is that as much as possible, people that are interested, you should be able to use machine learning modeling scheme in your own different areas of endeavor. You are an engineer, medical practitioner, irrespective of your background. So last week we demonstrated, starting with, based on the principle of let the data speak, the availability of data is very, very important. And we do get lots of comments, questions from people wondering how can they start from afresh from their own area, finding it difficult. So this is one of the essence of this, that we should be able to identify what are the things that you can actually use machine learning for. So that's why today we're going to first of all clarify, especially the supervised machine learning. We have different type of machine learning, supervised machine learning. This is the most accurate form of modeling. We call it predictive modeling. You can always be sure that you are going to get very excellent, good or acceptable or even excellent results. In this supervised ML, it is of this form. So we have y is equal to f of x. Not to simplify it. So supervised learning, this is a representation. You have an output, and then you have an input. And there is this hidden function. We call it hypothesis function that we don't know. Sometimes people write it as y is equal to h of x. There's this hypothesis function, or the model. This is what we call model. We don't know it. However, every system you want to work on can be subjected to this. So it has two stages. The first stage is the training stage. This is by way of revision for us. The training stage. In this stage, this y is equal to f of x. During the training, we know y. We also know x. These are known. These are the inputs. These are the features. So you have to find a way of establishing, is there any feature in my own area of practice or specialization that can fall into this kind of relationship? Y is equal to f of x. These are referred to as the independent variables. Independent variable. Why this y is the dependent variable. And often, these variables they are always very easy. These variables are easier to get. For example, last week we used the example of diabetes as a case study. I'll come back to my example. Let's look at that data. Look at this data yesterday, the other time we look at it. We can see age. We can easily get the age of a patient. It's not difficult. We can get the gender of a patient. It's easy. Even the BMI, it's just a matter of measuring the weight and do some calculation. Is he a smoker or not? See? So these are very easy to get. However, the why that we are looking for, like to determine if somebody is diabetes or not, it's not something that you can just decide. It's not easy. So this is usually the characteristics of this X. So this X is characterized by being easy to get. So you can easily get it. However, this dependent variable, which is usually our target, is always difficult to get. It's very, very difficult to know. In fact, in some profession where you go to laboratory, to do experiment, we've had property that you spend like 2 weeks before the result of this Y will come out. And for this X, you can just take a measure, just put your material or your sample inside the machine. The machine will report the mass, the weight, and whatever basic characteristics. So what machine learning is trying to do is, if you have these raw data that are very easy and cheaper to get, then you can just struggle to get some of this Y out for us, at least some sample, no matter how few you can. Then once we can train our model, so you are going to have the Y. So during the training process, we know Y and then we know X. So we are looking for this F. This is unknown. So during training, Y and X, we know them. They are known. They are known variable during the training. However, the F, or sometimes we call it H, is what we don't know. It's unknown. So we need to provide enough data set so that our system can be trained to be able to identify what is this unique relationship that is holding them together. Because if I'm able to understand this relationship that is holding this X and Y together, then it means subsequently in the testing stage, we see how Y is equal to F of X. But after training, now our F is known. F is known. As usual, X is always easy to know. You can easily know that they are known also. X is known. Now your Y, which is very difficult to get, is unknown. In every area, that Y is always difficult to get. Like I said, in the chemical profession where you have to go to laboratory to perform experiment, it could take you weeks sometimes to get one value of Y. The same thing in medical. You can get a lot of data from your patient easily, but to determine if that patient is sick or not sick, it's not something you can do. You need a medical doctor to do that for you. Even that the medical doctor himself or herself need to have experience to be able to discern it after making a lot of medical tests. Sometimes there are diseases that are similar in attributes. Sometimes after several experiments in the laboratory testing, there could be some diseases that are having similar attributes or similar symptoms. The doctor also must still be confused. So, however, if we can have our data set, so this decision that is always very challenging to take, once we have trained our model to recognize the hidden relationship between the input and the output, then we can go to the testing stage. During the testing stage, F is now known because we have gotten the value of N, we have gotten the representation of F or H, as the case may be, during the training training stage. Then we can then move on. Since X is always easy to know, so get your facts together, and then this Y can now be determined, which is usually the more difficult to know. However, the sacrifice you have to make is to generate some Y at the cost of training. So you need a complete data set for training. This is why the challenge actually comes in. So once you have some data set for training, then automatically H is already generated for you during training. We cannot use that hypothesis function during the testing phase. There you know X that is always easy to get, and then F is already known, or H, so you can always get the value of Y. So Y is equal to the H of X. So put the value of X into the hypothesis function or the model that you have built, or some people call it is a program. It's an auto-generated program by the ML process, machine learning procedure. Once you have that, you can easily have what you want to do, irrespective of your area of specialization. And then, of course, as we have always made us realize, this is where we have to prepare your data. Data preparation is very, very important. So once you prepare data, feature engineering, sometimes it might be optional at the beginning, then you might have to have data modeling. This is why you are going to use the machine learning algorithm. So check what you have put together as data set to see how much of training performance can you achieve. And then this good news is there's always room for you to go back. In the building block of machine learning, there's always room to go back. You can either go back to your algorithm model, hyperparameter optimization to make it better. You might have to go back to feature engineering. Maybe the feature you have selected, they are not the appropriate one. Sometimes you might have to go back totally to the data preparation stage. So it's always a kind of an iteration. You see, it's an iterative process. You are not likely going to get it once and for all. To me, that is an advantage in itself. It means you don't need to waste too much time to make sure you get the best. Go into the data modeling process. If there's need for improvement, you can always go back. No need to worry about. So having established this, now we said last week we covered the example of diabetes. We even said that you can actually deal with the case of data set that you don't even need to go to clinic for anything. Just basic interview for people. So data could be obtained by carefully answering questions posed by medical practitioner or inform people on such tasks. So you can see you ask for the age, you ask for the gender, you ask a lot of questions, do you experience weaknesses, and some other terminology that might need to be, the meaning might need to be explained to the people that are concerned, because they could be ordinary person who doesn't understand this term. However, you can also choose to even ignore some of those terminologies that an average person cannot answer, because especially if you have a project, we are working on a project that we want to take using machine learning to quickly detect if somebody is diabetes. We want to take it to the grassroots. A lot of people suffer from diabetes for long without knowing. So can we ask simple question? What's your age? What's your gender? So do you experience weaknesses in any part of your body? So do you express itching? Do you have visual blurring? So do you have delay healing? Whenever you have a wound, does it take time for it to get healed? So then you experience what you call obesity. Okay, you need a machine to measure yourself to be able to know your weight and the like. Okay, we don't even want this. So can we have 1, 2, 3, 4, 5, 6? These are very simple interview questions that everybody should be able to answer. And then you can go into your laboratory and start experimenting, get data set as much as possible on this. This is the class. Each of the person that you have to get the training data sets, maybe from hospital environment, get to the hospital environment, interview people that are waiting to see their doctors who have been confirmed to have diabetes. Ask this question from them and document their responses. Then after that, you can then go ahead to those people who are free of this disease and also get their data set. Because this is classification, you're always going to have the positive class and the negative class. And based on this, you are going to train your model appropriately. So based on this kind of information, you can train your model and then see how far you can go in the system that you want to build. Now, for this example, again, especially now that we decided we want to use only age, gender, weakness, itching, and then delayed healing, only 5. Can we use these 5 to actually be able to identify if somebody is suffering from diabetes or not? Then you go into your experimentation, get as many data sets as you can, and then try to figure out from your modeling, let the data speak, based on the principle of let the data speak. So now we're going to go into our modeling environment. As usual, let's open this Weka. So we're going to click Explorer. So you click Explorer here. So Explorer will open for you, and then you can then load your data set. Here you have to open your data set. So you have to go to the location of your data set. So this is look for where your data set is located. Then you have to see here, it's empty here. We have to change the file type to CSV. Because data set is in the CSV file. Then this is the interview-based data. Yeah, you can see this is the complete data set for all those cases. However, we want to use only 5. So I'm going to remove, we don't want this, we don't want this. Yeah. So we want to remove anything that might be a little bit difficult to interpret for the interviewee. So partial paresis, muscle stiffness. So we can remove them. So we are left with 1, gender, sudden weight loss. Yeah, this is easy. Anybody can answer this question. So do you suddenly experience that you have a weight loss? Then we have the weakness, part of your body. We want to also avoid this, anything that people cannot easily understand. Visual blurring, are you having issue with your eyesight? Delay healing, yeah. Even obesity also, can we remove them? Yeah. So now you're having 1, 2, 3, 4, 5, 6, 7. So these are basic interview questions that we can ask anybody out there. And based on that, we have already data sets that can do this work for us. So this is so then you can be able to go to classify, select the classifier you want to use. And then this is, let's go for IBK, K nearest neighbor. K nearest neighbor is one of the very simple machine learning algorithm. So working on the principle of, like, show me your friend, I can tell you the kind of person you are. People that are closer to you, they are likely going to exhibit the same attribute like you do. So if you live in an environment, most likely the people living in that environment also, they might also have some characteristics similar to you. We use this in kind of maybe building model to determine neighborhood that might experience crises or criminal activities and the likes. So now, our data is loaded. So this is maybe visualization. So once you select percentage split or cross validation, these are 2 methods of training your model. You want to train the model now, and you can build, start. The model is trained. You can see here now that with just these very few features, we're able to achieve 90% accuracy. That means if I use this model, a model has been built now using the data set, using 8 attributes. So there are 520 instances. It means with these instances, I can be able to judge if somebody is having diabetes or not, if I can ask them these basic questions. See, it means we can build an attribute. I mean, we can build a kind of interview stuff to be online. Let people answer this question. Then we can have the system available for everybody on a mobile phone. Okay, check yourself for diabetes. That's going to be an kind of interventionist system to prevent people from silently suffering from diabetes without knowing. Because not everybody can visit a medical doctor. Even if you want to do, you get there, the queue is just too much. Sometimes people live in the village, or sometimes someone is traveling, is so busy, he doesn't even have, he has the access to the medical checkup facility, but he has no time to do that. So on the go, somebody can answer these basic questions. So if someone can answer this basic question, and then we can be able to determine with 90% accuracy. We are just starting it. I think that is something that is interesting to work on. Of course, we still have to work on it. 90% in medical, we are not very happy with that. We want it to go to as high as possible, to like maybe 100%. This is where we're going to talk about how to do hyperparameter optimization. I believe we have had a lot of lectures on that before. So we click on this. This is KNN. You have to change this hyperparameter. These are the parameters that will affect the performance of your algorithm. So we have to try to modify them. So we can change this one to become like maybe you can say 5, no 3, because we're having 2 classes. It's classifying it into, is it diabetes or not? So yes or no. So if you choose 2, because there is voting process in K nearest neighbor, it will look for who are the 3 closest people to you. When it was 1, what it is doing is to look for who is closest to you. In all those data sets we got inside that we know they are either diabetes or not. Who is the nearest to you? That is K is equal to 1. If the nearest person to you is sick of diabetes, then it's going to say that you are sick. So now we want to, and we were able to get 90% when we use 1. So we want to increase it to 3. 3 means it to check who are the 3 people that are closer to you in terms of attributes, characteristics. You select them. Out of the 3, how many of them are diabetes and how many of them are free of the disease? If 2 against 1, then majority casts the vote. That is why we cannot use 2, because if you use 2, if there's 1-1, there's going to be confusion. So one person nearer to you is not, the other one is positive. Where are we going to push you to? So in k-nearest neighbor, if your number of classes is only 2, you don't use anything that is going to be an even number in that respect. So we can try 3, we can try 5, we can try 7, we can try 9, keep going until the result is no more improving. So now we're making it to 3, then we can run the experiment again. We can see making it to 3 actually reduce the performance to 82%. It means for this data set, let's make it 5. Yeah. It goes to 82. From 82 reduced to 80. It means so far the default value seems to be what is working for this data set. So that is 90%. So we are back to 90% when I change that number of K to 1 again. This is called hyperparameter optimization. We have to check for that. It means for k-nearest neighbor on this data set presently, except we want to do feature selection and some other ways we can improve the result. Then we might have to start thinking of using another machine learning algorithm to get better result for us in this particular case. So maybe you want to look into decision tree, or I want to use support vector machine, which has been reported that it's often achieve very excellent result. But we are not going to that one for today. So this is how we can start by just deciding on what is the feature that you want to use. This is the most important thing. Decide on the features, then try to get as many data samples as possible. Because it's very, very important that you are able to have the data sample for you that you can then use it for the modeling that you want to carry out. So let's look at the data again. These are the data so we're looking. You can see age. These are the distribution of the age, the minimum, the maximum, the mean. We have the gender. You can see they are majority male, then female. These are attributes that you think that may determine if somebody is going to be sick or not sick of this disease. And then sudden weight loss. Do you experience sudden weight loss? Is there weakness? Do you experience visual blurring? Do you have itching or delay healing? Depending on the area you are actually carrying out this modeling. So in similar way, so you have to always look at it clearly in your own case. So can I establish the relationship y is equal to f of x? So this is the beginning. So it's not that I have data sets. Sometimes you might have data set, the data set might not be related together. You have to look at this. Can you get data set that whereby you have x, you have x1, x2, x3, these are the inputs, we call them features or attributes. But they have a relationship together that can determine the fate of y. Do you have something like this? That their fate can be determined by this, we call this the independent variables, and this is the dependent variable. So the fact that you have data set does not mean that you can use machine learning to solve your problem. You have to look at it, okay, what can we do with it? Is there any attributes in my data set? If I want to gather the data set, you have to do some analysis first. Okay, can this problem be subjected to it? And the reality is, an average system that is real-life problem can always be subjected to being used for modeling in machine learning environment. So just look out for that relationship. Y is equal to h of x, either f of x or h of x. So do you have a Y that the value often depend on X? This X could be many. It could be X1, X2, X3, which we have also shown example here. Once again, we identify the age, the gender, the weaknesses, itching, delay healing, and few questions that you can ask from people. This is when we deal with this. It could also be in other areas of activity. It doesn't have to be in the medical areas. So once you are able to have that confirmed, let's look at this as an example. Another example, we have customer churn. This is a case study of telecom company. Customer churn. So let's say you are a customer company, a client who is interested in determining if his customer is going to run away or not. Then you have to first of all try to look at it critically. Okay, what are the attributes that you need to supply data for? You may have to look into their profile of the customer to get this information. So how many accounting weeks do they have? You see, how many account weeks? What is the contract renewal pattern? What is the approach of their contract renewal that they have all signed? What's the data plan that you have for them? Is it fixed data plan or what they call prepaid or postpaid? What is the amount of data usage by this customer? See, how many calls, daytime calls, monthly charges, the average field, is there any roaming minutes? Then we are going to have the target. This is the target. This is the why that we want to establish that relationship. It's not F of X. You have to know ahead of time. Okay, these are the likely data set that I might need if I really want to build this kind of a model. Then you now see, okay, where can we get this data from? Is it really possible to get data of this format? In this case, then we can go into, let's look at the data. For example, this is an example of this data. This is a telecom data set. You can see here the number of weeks since the account was open, the contract term, is it prepaid or not prepaid, the kind of data plan you are using. So what is data usage on the average? The customer service calls. Because customers that made calls to customer service regularly, they are likely to have issues and they might likely leave the company. This is the idea. If somebody calls customer service regularly, they need to fix your problem. Otherwise, you might soon run away from that telecom company. So they look at that number. So you have to think, what are the attributes that can determine the decision of a customer? The number of days, the minutes, the number of calls they make, the monthly charges, and then the average fee incurred. Is there any roaming minutes? Does he travel and use some roaming calls? Based on this, we can determine churn. Oh, this customer might run away or he might not run away. Sometimes you might not need all these features. 3 of them, 4 of them might be enough to determine which customer will run away or will not run away. So once you are able to identify the attributes you want to use, then you seek out to look for data set. Or you already got the data set, you have to analyze the data set. Does it really suit what I want to do? Is there any, where is the dependent variable? You have to identify. Somebody might just give you a data set. Where is the dependent variable? Okay, this is churn. Okay, no. Okay, this is like yes or no. This is likely to be the target. This is churn means the customer is leaving the company. We lost that customer. And no business want to lose any customer because a lost customer is the potential enemy of the company. It will badmouth the company. So we always want to make sure you don't leave. So they have to have enough data set to be able to do the modeling. So as usual also, we open our Weka, we open the data set. Yeah, this data set. So we open the data set. Yeah, I think this is here, telecom. So you can see these are here. So we go and open we want to use the IBK also. We can run our model. So this is starting at 89%. See, sorry, 87%, 0.36. This is the initial one. Is it okay? Can we improve it by increasing the number, if we increase, can you see? It seems to be increasing when I increase my K to 3. So I make my K to be 5. You can see it's increasing as I increase the number of K now. This is the principle of let the data speak. Remember the false diabetes data we use, when we increase K, the value, the performance goes down. But now for this data set of telecom company, as I increase the number of K, that is the hyperparameter value, it keeps increasing in value. I mean, the performance keep improving. So this is the practical demonstration of let the data speak. If somebody tells you that the best value of K is 10, sorry, it's 9 or it's 15, you don't follow it. It depends on your data set. Let the data speak. Now, with this particular second example, you can see that we are getting better result as I increase the number of K now to 7. Then it increases again. Let's see. It's still 90. So make it 9. Any improvement? You have to keep checking it until you found that there is no more performance improvement or it started going down. Then you have to realize that, oh, it seems this is the maximum value I can go in terms of the number of K. And of course, there's another hyperparameter you can also change. That is the Euclidean distance. We are using Euclidean distance, the distance measure. By default, it is Euclidean distance. It can be other distance method like Manhattan distance measure. So you have to change that also. Minkowski distance measure, Chebyshev distance measure. You have to, those are called hyperparameters that can determine the performance of your model. For details analysis of K-nearest neighbor, we've had a lot of our previous videos trying to do hyperparameter optimization. So we can check that those ones there out. Our interest for now is how do you move from actually defining a problem to actually implementing it, which we've noticed based on comment we have been receiving. A lot of people are finding it difficult to start from a place. So you can actually do it and you can actually start easily. So get attributes of those areas of your interest. Look at how they are related together by it. Can you establish a relationship of y is equal to f of x in that area? Is it possible? So is there any y that is very difficult to get in the laboratory or in your area, and you have some x that are often easy? The value of x, the independent variable, that are often easier to get. What's your age? What is your gender? You see? You can easily get that. Why this y is always challenging. So this is how you know, okay, there's a relationship between it and the other one. Like the example we just shown to us in the case of telecom, you can see here that these are basic information that the telecom industry can just get it directly from the profile of the customer. But to determine who will run away or who will not run away is not something easy. You cannot just look at the face of a customer and say, hey, this customer will run away. You cannot do that. It's difficult to judge. So all this easy to use data, why don't we turn it into decision making by building a machine learning model that can make life easier and prevent such company from losing their customer? This is another example for us. Sometimes I want to even increase the data set. I noticed that it's in the account week, they just give us, they did not include age and gender. Maybe next time I'll ask them, please, I need age and gender of the person. Maybe it will add to information that determines who will live, who will not live. See, I want to increase the number of features. Maybe age is very important. Maybe gender also is very important. Because if they are youth, maybe youth is more likely to have in need of a lot of things that I can't get what I'm looking for in this company. I need to go immediately. So for age has been ignored in this data. We can bring it back. It means next time I can tell my client, oh, look, you need to provide age and gender as part of the data set you are going to supply. So this is just try to demonstrate how you can move from establish a case for the use of machine learning model in a particular problem solving activity in any company or any client, or even for your own individual work, either as an engineer, as a businessman and women, and also whatever profession we have of choosing to embrace. So this is where we're going to have it for the day. So if you have any questions. So we're going to take a couple of questions before we call it a day. So hopefully we all have been able to see, once we have established that there's always a room for model training. You can always improve for a model. Either you go back to hyperparameter optimization and most of other stuff that we've all discussed earlier on. So we implore that you refer to our earlier videos in our YouTube channel. If you have any issue, then feel free to always get across. Thank you very much for listening.